All right, so I just wanted to start today by acknowledging that Brock University is found on the traditional lands of the Anishinaabe and Haudenosaunee peoples. And with that, thank you all for coming today to my talk on the effects of social status on aggression in a facultatively species, Xylocopa virginica. So to start off with, Xylocopa virginica is a unique species for studying social behavior, and this is because they are facultatively social. So this means that the females of the species can nest either solitarily, and then if this is the case, they will exclude all other females from their nests, or they can nest socially, where they will be tolerant to other, often unrelated females staying within their nest over the breeding season. These nests are very costly for females to build, and therefore they will fight over access to them. And this is possibly one of the reasons why some females may settle for social living, since they are unable to exclude other females from their nest. So to start off with, I have a figure here that shows the activity patterns for female Xylocopa virginica over a typical year. You can see that they wake up from hibernation usually in April and then begin a period of nest cleaning and expansion where they are active but stay within the nest. This is followed by two separate foraging phases, the nestmate and brood provisioning phases. And so during the nestmate provisioning, some females will go out and forage and bring back food for their nestmates. And these are mainly social females. And then in the brood provisioning, we have a larger portion of the females that go out and forage in order to provision their own young. Starting in July, the foraging sort of dies down while the brood develop and then eventually emerge in late summer, where they will forage for themselves for a little while before going back into hibernation to do it all over again next year. So the colors on this figure represent when we theorize the dominance hierarchy of the social nest to be open and or fixed. And so the key times here where the dominance hierarchy is open is in late spring and early summer in the lead up to brood provisioning. And this is important because as the lead up to brood provisioning is happening, we believe that females are trying to position themselves to best take advantage of that. And being at the top of the dominance hierarchy can help them produce more young. Later on in the year when brood are no longer being provisioned, this is no longer as important. And so it doesn't really matter if you're at the top of the dominance hierarchy if you're not going to produce any young anyways. So I hypothesize that there will be greater amounts of aggression displayed by solitary females because they are intolerant to other females within their nest. And so what I'm predicting is that we'll have a set of dyads that looks a little something like this, where you have the greatest amount of aggression in dyads with two solitary females, the least amount in dyads with two social females, and then an intermediate amount with a dyad with solitary and social females. Over the course of the 2021 field season, I was able to 28, 13, and 11 dyads respectively for these different groups. So in order to test this hypothesis, I used circle tube observations. And so this is when two bees are placed in either end of a clear plastic tube and is then brought around in a circle. And this is going to force the bees to interact with each other. Pairs were all random and always consisted of non-nestmates, so unfamiliar bees. And they were placed in at the same time after being cooled on ice for ease of handling. And then observations lasted for 20 minutes after the start of bee activity, where I observed and documented all behaviors that occurred. The reason that I wanted to use circle tubes is because they sort of give a rough representation of the inside of a nest without having the added complication of ownership be involved. So far in my analysis, I've analyzed 3 different aggressive behaviors. The first one, as you can see on the right here, is passive blocking. And this is when a female uses her head and or abdomen to block the tube from the other individual for her. The next one is pushing, which involves a female putting her head up against her opponent and providing consistent pressure to push around the two. And finally, we have C posturing, which is when the female curls her abdomen underneath her head so that both her sting and her mandibles are facing the. So as I touched upon earlier, there are several different times throughout the year where they find themselves for Xylocopa virginica, but the two I want to focus on today are the nestmate and the brood provisioning phase. These phases are important because they represent the foraging phases of the female life, and therefore when they are easy to find and capture, as well as being likely targets for the dominance hierarchy. So what we expect to see for this species is two separate peaks of foraging activity, one during the nestmate provisioning and then one during the brood provisioning. And you can see here my data for 2021. So the total foraging effort is just a measure of the total amount of pollen that's brought back to the nests on day. And you can see that there are in fact two peaks, one in late May, which is nestmate provisioning phase, and then one again in June, which is the brood provisioning phase. So all of my behavioral observations happened after June 4th here, which means that all of my behavioral observations happened during brood provisioning phase. Now, this is important for a number of reasons. First of all, it's important because it means that both solitary and social females are out. As I talked about earlier, during the nestmate provisioning phase, it's only some females that are foraging, and these are mainly social. This also means that both solitary and social females are foraging for the same purpose, and this is to provision their brood and therefore their offspring for the next generation. Really, it means that the stakes of nest protection are increased because females have brood inside the nest who they have invested a lot of. So with all of this in mind, I combined all of the three aggressive behaviors into a single category, which I have labeled aggression. And you can see here that, in fact, social dyads did have less aggression than solitary, and social dyads, that this was statistically significant. However, it does not appear that there's a sort of immediate with solitary social, at least not statistically significant. So after finding this, I decided I wanted to look a little more closely at the different specifically. And so here we can see that the same general trend is seen with all three aggressive behaviors, pushing, C posturing, and pass blocking, but that the only one where these differences were significant was C posturing. Once again, with social less aggression, but they're not really being a huge statistical solitary dyads. Finally, I wanted to look at specifically the solitary social dyads, which I did here, and to look at which individuals are behaving aggressively. And you can see that in the case of pushing, at least, there is statistical significance that the solitary individual is the one initiating most of the aggressive interaction. And this is interesting because of the three aggressive behaviors that I've looked at so far, pushing is really the most overtly aggressive.
James, can you hear me? Sorry, your audio is getting a little bit choppy. Would you mind turning off your video to see maybe if it's your connection? Okay.
That's a little better. Should I go back a few slides or?
Yes, particularly this slide for sure.
Okay. All right. So what I was saying for this slide was I wanted to look at the solitary social dyads specifically and see which individuals are the ones initiating the aggressive behavior. And you can see here that in the case of pushing, at least, it is statistically significant more likely that the solitary individual is the one initiating the aggressive interaction. And that this is interesting because really out of the three behaviors that I've looked at so far, pushing is really the most overtly aggressive out of the three. So what does all of this mean? This all supports my hypothesis that there are differences in aggression depending on social status, but not exactly how I predicted it. So instead of having the most amount in solitary, and then an intermediate amount in solitary social before going down to social, what we're seeing is a bit more like this, where there's not really a huge difference between the two dyads that have solitary individuals in it, but that there is a decrease in aggression in social. Also, it shows that solitary females are more likely to be the aggressors in dyads that have both a solitary and a social individual, which again is supporting the idea that there is behavioral differences in these two different social. So what's next? For me, what I really would like to do now is I'd like to compare amongst social females. So this is going to get covered in much more detail after the break by my lab mate, Lyndon. But essentially, there are a few different types of social virginica. The two important ones for my analysis, at least, are primaries and secondaries. And so a primary female is the dominant forager and egg layer in the nest. And then secondaries are subordinate to her. And they will do some foraging and egg laying, but not nearly as much. So I believe that the primaries must be maintaining their dominant position some way, and it's likely that they use aggression to do this. So I believe if we could continue this analysis, we would see that not only are solitaries the most aggressive, but then that primaries are the second most aggressive, and then secondaries are the least aggressive out of all of the females. And then finally, what I would like to do is I'd like to consider more than simplified behavioral categories like I did today. These simplified categories are great for making some basic analysis, like where there is the most aggression, but the orders in which behaviors occur, the context in which behaviors occur, things like that can also be very important. And I would love to do some more analysis on those to gain more insight about them. So with that, I would like to thank you all for your attention today. And I would like to thank my lab mates for all of the help with this presentation and with my work in general. I could not have done it. So thank you very much.
Thank you, James. That was a great talk. And sorry for interrupting you in the middle of that.
It's all good. If there was a problem.
I don't know if it was the microphone or the connection, but you know what, you pulled through and it was great. So we do have one question in the chat from Ralph, and Ralph asks, on the aggression red color table, why are there more aggression displays between social compared to social solitary?
So that's a great question. There did definitely appear to be if you just kind of look at the graphs, but as of right now, I haven't really found any statistical difference between those two groups. And that could be for a number of reasons. But as of right now, no.